Hi everyone, welcome to today's webinar. We are going to be talking about what's new in PSIM 2020. I'm Albert Dunford. Other things, so do download those that PDF. That PDF is my slides that we're going through. I don't have a lot of slides. The main thing I'm hoping to show in these slides is there's a lot of links. A lot of what we're going to talk about today I've covered already in other webinars or other resources that cover that information. So I'm just trying to link you out to those other more in-depth things. So I'm not spending 4 hours here talking about, high frequency motor drives or, linking to Ridley Works or linking to Typhoon Hill or talking about the X bar on the C2 on the F2804X processor. So if those things are of interest, do go and look at those resources. Okay, let's get going here. So this is an international webinar. If you are joining us from a distributor area, you can refer to this little graphic here to see who's your local person. But yeah, otherwise you're covered by me. I work for PSIM, and we cover North America and other regions. So if this is your first experience with PSIM or you just want a little bit of a history here, PSIM first started as an ideal switch simulator for power electronics that co-simulated with Simulink. So our founder, Dr. Jin, found that Simulink struggled with power electronics, so he wrote a tool. Since then, we have now sort of expanded our functionality to include device-level simulation, so you can link out with SPICE, and you can also the aspects of MATLAB Simulink that you require for power converter design and simulation are now incorporated into, so that's native to PSIM. So PSIM should be a single source tool for power electronics design and simulation. When it comes to functionality here, we do have, so some of the new things coming here is the link with Ridley Works. So Ridley Works is a power converter design tool with magnetics design as well. We are now exporting out of Ridley Works into PSIM. Smart Control is also a control loop design tool that we sell. So Ridley Works we don't sell. We just export. We just link with the output of that. Smart Control is another tool that provides some same kind of functionality. It does not have the magnetics design, but it does allow for some other topologies to be done or general control design to be done there. We are also linking with Typhoon Hill. Typhoon Hill is so now you can export your PSIM schematic into the Typhoon Hill interface, the Typhoon Hill system. That is a new feature with 2020. We'll look at that quickly here. We're also showing new targets. So the 28004X is new with 2020. That's a new Piccolo processor from Texas Instruments. That processor and the F2837X, we have some the X bar support, the EPWM, so advanced EPWM support, comparative triggering. There's some very interesting things you can do with that those two processors now when it comes to advanced triggering of PWMs. There are some links to some additional files later on and webinars covering that. Otherwise, we're just making improvements in general to a lot of things, and let's kind of go over what's new here. So importantly, the DSIM engine will be released as well in the middle of June, around the 15th. That's what we're currently planning for. So mid of June is when DSIM should be coming out, and we've got with PSIM there's dual model compatibility. So DSIM is a separately purchased tool. Please do remember that. So it doesn't come with PSIM, but you can have a dual installation. So there's some things there. There's a new and faster AC sweep. So this is the one we worked with Dr. Ray Ridley. This is a faster sweep for frequency responses of a converter. We've got some new scripting functions. This is and some new support features in scripts to help making using scripts easier. And then we've got phase 1 of our rework support and help resources. This is a pretty important project we're embarking on. This has been really One of my other colleagues, Dr. Fernandez, has been helping us on this one. He's been really working to help make our resources more integrated and all that kind of thing. We'll have a look at this. This is a pretty important project that we're embarking on. And then we've got some new models here. The most important one being this PSIM with the high frequency input impedance. So we'll look at this. So we had the induction machine model with the high frequency input impedance. This PSIM with the high frequency input impedance, this is important when you have a transmission line, well, a long cable at the front of your machine between the drive, the switches and the machine. There's some, you need the proper termination impedance to get the wave reflections correctly. And then we've got our some new sensors and other control elements we'll talk about quickly. We talked briefly about the export from RidleyWorks, export from PSIM schematic to Typhoon, and then the new embedded code generation stuff. We'll talk about that quickly. So let's keep going here. So the Simulink. So DSIM, if you've not heard yet, DSIM is the new simulation engine that we're going to be selling. It can be purchased separately from PSIM or bundled with PSIM, but is a separate product. DSIM, however, is not a general purpose simulation tool. So there are some limitations specifically to switch configurations, which I've listed here. We're also limited to digital control or open loop style control. We're not allowing at current time, peak remote control style, comparator type stuff control, but you are allowed motor drives. So there are some things you have to build out of any combination. Your converter has to be any combination of this setup. So there are some limitations, but in general, this is pretty. Will cover most applications. Kind of targeting the niche application right now would be like a microgrid type of thing. So that's going to be coming. There'll be a separate webinar covering that, but there will be dual compatibility. So you will be able to run DSIM, a schematic built for DSIM in PSIM and PSIM with DSIM. So you'll be able to use either engine. The DSIM simulation will obviously be much faster, but you'll be able to at least verify that the DSIM engine is giving you good results if you don't trust, okay, the sim is so fast, how can it be accurate? Well, you can actually run a portion of it with PSIM and verify what's happening because there'll be dual compatibility there. So then definitely when you download this handout, these are live links over here. Let me just draw a circle around those. Drawing tool, pen. So these links, so there's links on certain pages on the handouts that you can download. Those are live links, so you can click on those and you're going to get bounced back to a webinar that covers these things in a little bit more detail. Okay. Next up is the faster AC sweep. So this AC sweep is one we developed with the help of Dr. Ray Ridley. If you're familiar with who he is, he's pretty well known when it comes to control. So this one is in the library. It's called AC sweep with the 2 in parentheses. This is the parameter set for it. It is so there's 2 other types of AC sweep in PSIM, and I'll kind of cover those and how they work. These are for doing, what happens is if we look at the settings here, we're starting at 100 hertz, we're going to 10 kilohertz, and there's going to be 51 data points used. These 51 data points are going to be spread in a even log fashion between 100 and 10 kilohertz, and these individual frequencies are going to be run individually. So we're going to do 51 individual time domain simulations with that injected perturbation. What's the coverage of DSIM? So there's a question, what is the coverage of DSIM in terms of MMC? We'll just talk about that for a second. So yes, you can build a very large MMC using, this block or this block, so the chopper block or the H-bridge block, to build up a very large MMC system if you want, or to have multiple MMCs working together. So I have an example that has a 10-unit MMC with 120 active switches, so with 10 inverters using them, so 1,200 active switches with this, or you can go H-bridge chopper style, and build up something that way. So definitely, so like I say, a single phase system. So definitely there's lots of strong support for MMC with PSIM. So to answer that question. Laser pointer. Okay, back to the sweep. So where were we here? So so the individual, so we were going to run 51 individual simulations. We're going to inject that frequency, and then we're going to measure the gain and phase at the points of interest based on the reference frequency gain and phase, gain and amplitude, phase and amplitude. So so the thing with this sweep is we need to define the steady state time. So what's going to happen is when we run the simulation, it's going to run the converter for this predetermined amount of time before it starts injecting frequencies. So what's going to happen is in this particular instance, it's going to run to 100 milliseconds, and then it's going to use that point as a starting point for the 51 perturbations. And then what's going to happen is those perturbations are going to be run simultaneously. So the nice thing that we can do here with PSIM is the way the engine works is we don't need, we can, if you have 8 cores or 16 cores or however many threads your CPUs can run, we can run that many simulations simultaneously using the initial run as the initial conditions. So this can, as you can, and then what we do is we run for a few cycles here. And so in this particular instance, we are not detecting steady state. So we're looking to ensure that the converter is going to be stable at that perturbation point after 3 cycles. You can increase the number of cycles here as well, but this is the minimum is 3 cycles. And so what happens is we run the first 100 milliseconds, and then we're going to run 51 simultaneous simulations on an open core. Whenever they open up, we're just going to keep running them. And then we're running each one for 3 cycles, and then we're doing the extraction. And you're able to shape the perturbation waveform here. And then this flag for waveforms here, this will save all 51 of those perturbation waveforms. So you can go back and check to see if you see an anomaly in the Bode response output. You can go back and check to see if things were stable. So this one is quite quick, as you can probably imagine. There are 2 other AC sweeps, though, which I want to highlight here, just so we're familiar with how this one is different from the other ones. So there's AC sweep and AC sweep 1, and these work the same way as this one, and you're running individual frequency injections, but these ones have a steady state detection. And so they will run to up to 60 cycles of that particular frequency to detect steady state before moving to the next frequency. So these ones can work. They work a little bit slower, obviously, because they're doing a steady state detection. But at the same time, there's some other optimizations done with this one that make it run a little bit faster. But this one is pretty good when it comes to unstable system or marginally stable systems, let's call them, or of that nature. And then we've got another one here, the multi-sign, or the M sign, or the multi-tone, or some other words used to describe it. What this one does, it injects all the frequencies in one simulation. So this one is also very fast, but it can be prone to errors. We have 4 sweeps now, and with those 4 sweeps, you should be able to get a frequency response out of any kind of topology you ever can possibly imagine. And then you just need to play around with you get a feel for which ones work fastest with which other one. Okay, so definitely there's some links again here on how to set these up. I have not yet done a tutorial video that covers the new sweep in detail. So do check back to the website for more information on that, or to our social media feeds to see when those things will come. Okay, so bridging to scripting here. So in scripting with PSIM, if you've not done that yet, our scripting functionality is very similar to MATLAB Simulink's M files, and we've added some new tricks here. So now, if you open up one of our example scripts, if you double-click on a function, so you highlight it and then click F1, it's going to pop open a help browser, which is going to describe to you what that function is doing. So that's a really powerful way of looking at our examples and then looking to see and understand how they work. So this is very, I think, very good. And then we've got a whole bunch of new functions that deal with mostly with calculations with arrays. So like loading in a waveform, you can extract a waveform by just pulling by using an array fetch with the waveform name, and then you can sum it very easily with just with one function call. You don't have to write a while loop. You can find the maximum or minimum without having to go through and look for each point individually while in a loop, and you can also average it very easily as well. And you can build formulas and functions just as you would. So you could say you define a function which has variables in it, which are then functions of other functions, and you can plot like build a bode plot of something if you want to. So this is a really, I think, very, very good. And we'll look at these with some simulations a little bit later here. Okay. And then this bridges us to our sort of phase one of the help and support. So we'll look at this in PSIM in a moment here, but we are really making a very strong effort of making our support resources better integrated. So we've got tons of tutorial videos, we've got tons of webinars, we've got tons of example circuits and PDF tutorials and all sorts of things that are separately defined right now. And if you say you open up an element and you wanted to watch a video relating to it or find an example circuit relating to it, that was kind of difficult before, and now there's clickable links that allow you to get to all these things. And the other thing that we had is we were still kind of expecting that people would read the manual, and we've kind of made the decision that we're not expecting people to read the manual anymore. So we are including more of the derivations and detailed information that was previously in the manual as part of the actual help. And so there's not going to really, the manual is going to potentially kind of get absorbed into the help as a whole. So there's a lot kind of going on here. And so this is phase one of it. Phase two will be tighter integration with the website resources. So right now, everything kind of exists as PSIM offline, and then phase two will start to include, it'll be a seamless link back to our resource section on the website as well. So you'll be able to get into our forums and knowledge base, look to see what webinars are available, all that kind of stuff. So really, this is a pretty important improvement with regards to how you're going to access support and learn about how to use PSIM offline. Okay, so then there's the webinar, there's the link with RidleyWorks. We'll look at this quickly, but essentially RidleyWorks is a design tool for power supplies. It includes magnetics design, and you can export the design from RidleyWorks into PSIM, and there's a webinar that covers that there. Again, if you download that handout that I've got linked here, all these links work. And then also exporting from PSIM to Typhoon. So again, check that. There's an hour-long webinar covering that link in detail. So so basically you'll click this button, and it's going to take this schematic and convert it into a Typhoon schematic. There's a few other things that you can define, and we'll look at that quickly, but essentially then you can compile it directly from Typhoon, and then you should be able to run very quickly the PSIM schematic in with the Typhoon system. And then the new processor, the 2804X, is now supported, and with the 2837X, the X-bar and advanced PWM control is now properly supported, and that is also supported with the 28004X. So in this case, we can trigger off of an analog signal, so use the onboard comparators to trigger the PWM. We can use the X-bar, which maps other PWMs and defines logic so that you can have other switches trigger off of other switching events or combinations of logic of other switches. It gets quite complex. If you're getting into this, a typical example would be like a phase shift full bridge converter with peak remote control, where you have an active secondary rectification. And so you're triggering the phase shift on a peak current trip signal, and then you are then triggering the active secondary switches based on the on times of the primary side. So we'll look at that example quickly here, but definitely there's an hour-long webinar that covers this in detail. So definitely we're not going to cover that in detail today. I'm just making sure we're running well on time. So definitely check that out too, okay? And finally, finally, this is the high-frequency machine model for the PMSM. We did have one for the induction machine that was released with version 12. The PMSM one is now ready. We'll look at this quickly, but essentially this is the use case where we have a motor drive system where we've got the inverter, and then we have a long cable. So we've got a distributed cable model here with a hybrid pi style circuit where we've got LC, so self-inductance, mutual inductance, coupling capacitance to phases, coupling capacitance to ground, where all of those things are defined, and we've got a distributed model there. And that distributed model is so we've got some high frequency interactions that are going on there, and then we've got our machine drive here. And to get the proper reflections back down the cable, we need the proper termination impedance for that, and that's what's covered by the machine model here. And then we also have we're linking it to the chassis, so we can have the common mode noise issues as well. So we can link all the way back to a common ground, and then we've also got coupling here from the individual devices to the common mode, which would go through the heatsink. So we can model all those sorts of things quite well. And then these switches are level 2 switches, so we've got the right dV by dt and di by dt being injected into the cable. So there's lots of interesting things you can do with this sort of simulation. It's not going to be a short simulation, I will tell you that right now, but it at least is going to give you good results. And so then you can look at reflections and overvoltages on the terminals and issues at the switches, and then add in a filter circuit here to slow things down. So there's lots that you can do with this, and that's covered in this webinar here. I spent about an hour talking about that a couple weeks ago as well. Okay, and then there's just a summary of links so that you don't have to go through each page, but definitely download that PDF, and then you should be able to click on all these things and kind of get to more information about things in general. Okay, let's take a quick peek here. Okay. So there's a question, will this work with simulating lightning and other EMI type issues regarding cable impedance? So good question. So you could simulate a lightning strike or something of that nature. So let's have a quick look at the cable model that we have. Cable. So this is the cable model. Where's my pop-up? I'm missing the attributes box. And I have to, sorry, I've got a lot of windows open. I just need to find where the pop-up is. There it is. It's hiding behind the questions tab. Okay, so let's, okay, so this is the cable model. And let me just, and there's a couple other questions coming in, one at a time here. Okay, so this is the cable model, and this is the equivalent circuit. So this gets repeated with the number of sections that you're defining. So we've got LC, and then another one will show up LC, 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 and it'll just continue along the way. So if you wanted to simulate a lightning strike to the cable, you could have, you know, 2 of these defined. So you'd have something like this, where we've got it in the middle here, and then we've got this connection here, and then we can strike the middle of the cable. So we could have, say, 10 sections on that side, and 5 sections on that side, like 50 meters on that side, and 100 meters on that side. So 10-meter chunks, and then we could strike in the middle here with and use a defined source, a voltage-controlled source, to strike this with some sort of waveform that we want to define. And you would be able to simulate that kind of thing. Or you could build like an arc flash model, whatever you wanted to do. But yeah, you could do something like that, and then you should be able to then monitor the impact of that. That would be an interesting simulation for sure. And maybe I'll think about maybe building an example, but that you could definitely do something like that. So these cable models are distributed, so you could simulate a strike at any point on that cable if that was something of interest. Okay, other questions here. Is there an artificial neural network or other advanced control algorithms in the new PSIM? No, there is no element that defines that, but you can use the C blocks to define all sorts of other custom code or link to a DLL file that does that kind of thing for you. Can we define variable parameters such as time dependent, such as a capacitance and resistance during the simulation? Yes. That has been around for a long time. Is there any drawbacks or shortcomings to SimCoupler or co-simulate with MATLAB Simulink? Okay, is there any drawbacks to co-simulation with Simulink? So in general, it depends on the link with Simulink has been around for a little while, and let me just open up an example that shows the link with Simulink here. So here's a drive that is linking with Simulink where the basic example is all in PSIM is here. So field-oriented control of this PMSM, and in this one the control is in Simulink. So in this particular instance, the recommended system here is to pass back these waveforms. So we've got the currents, the speed feedback, and we're passing back into PSIM the modulation waveforms. I have seen people who pass back the gating waveforms into PSIM, and that's not really a very good idea. We want to make sure, like, leaving the gating waveform generation in PSIM is best. But otherwise, when it comes to linking to Simulink, with simple systems, it's not too bad. But as you get more and more complex, there can be issues that you run into that require some help from us to kind of figure out the best way of passing the signals back and forth between PSIM and Simulink. But definitely, there should be no real reason to start a new design with a link to Simulink. All of the blocks are built into PSIM. You should be able to do all of it from inside of PSIM, which will be a much faster simulation. But in general, if you were to do a motor drive in Simulink with nothing in PSIM, it'll be slower than doing the link to PSIM where PSIM handles the power stage, and then everything inside of PSIM will be the fastest. But yeah, we've got, PSIM definitely has a much wider selection of machine models, a much wider selection or possibilities for a more robust solve of the power stage. And then we've also got our own motor drive design modules for field weakening, torque parameter, field weakening control, all that kind of stuff. So, it all kind of depends on what you're going to do. That's a pretty general question. Will there be more models of actual devices, nonlinear devices such as MOSFETs in the future? So with version 10, we started adding in level 2 devices. So those are MOSFETs and IGBTs and diodes that have nonlinear switch transitions. So those have been around for a little while now. We're going to be adding potentially a nonlinear capacitor in. So that's going to be added in. And can EMI, common mode, differential mode, noise spectrum be drawn in PSIM? Yes. We'll look at that in a moment. Can DSIM compute power losses in both hard switching and soft? So there's a question here about DSIM. I'm not going to answer too many questions about DSIM on this webinar, but PSIM, if we use the thermal module in PSIM, it can compute switching losses with hard or soft switching. DSIM can also simulate those things as well and do switching losses. So yes. Is there now an EM transmission line model in PSIM coax that takes RF? Is there now an electromagnetic transmission line model in PSIM, i.e. a coax cable that takes RF effects into account? So if we're looking back at this cable model, this cable model we can put in. This is the equivalent circuit that we have, which is RLC with coupling capacitors to the phases and then one common shield. So a coax cable where we have one line and then a shield to it, I don't know if you can do that by putting these to zeros in here, but you know, you could potentially build your own quite quickly if you're just, and then just have like a network like this and then just copy and paste it out if you wanted to, but we don't have one. The nice thing with this one is the number of sections, when you define that, it just builds out that out, but it's at the basic level, it's just building this out for you. So, you know, PSIM can simulate those sorts of things very easily. So we can have very small inductance values and capacitor values that get distributed along this cable, and that's not going to be an issue for PSIM to solve. That very, what's the right word for the state-space matrix? That sparse, I think is the wrong word. Stiff, very stiff state-space matrix equations, very stiff state-space matrix equations are not an issue with PSIM because we're not using state-space matrices. We're doing a nodal solve at each time step. We solve the full simulation without any interfaces, so that's not an issue. Where are we here? Okay, so next question, could we use PSIM as a simulator to control firing switches? So PSIM does not drive external hardware. We generate code. Oh, okay. So Chad, there's a question. Yeah, we'll talk about your question offline. Can we use PSIM as a simulator to control firing switches? How about hardware and loop? So no, PSIM is an offline simulation tool. We generate code that can be used on the PE Expert 4 system or on the C2000 processors, and those are going to be systems that you would use to control hardware. So PSIM is not going to ever control hardware. If you're going to use a hardware and loop system, you can export your schematic from PSIM to Typhoon to do that kind of stuff. Okay, so yeah, let's kind of look at some of what's going on here. So first off, let's look at the new help here. So we clicked on help, and we've got all of this information, and we're also getting a look at. So in here now we can look at motor drives that have this. So if we click on this, this is going to open up a schematic here, and we can see that right now. So there was a question about EMI. We can run, I don't know how long the simulation takes to run, but we can run the simulation, and we'll let that run there for a little bit, and we can see the common mode current down here. So let's just let this run for a moment while we talk about what's going on here, and then we'll see in certain instances, we'll see some applications where we talk about these sorts of things, tutorials. So these are going to be videos or PDFs, and then we'll also see related help topics. So we can, so this is all from the help in the cable model. So if we go down to the bottom, we can see we're actually, you know, if you're looking at this, you're probably interested in the PMSMs or the induction machine or a 3-level converter potentially. So if you click on those, you can swap out and start seeing what's going on with some of these other applications. We can see these things, what they look like. So there's a lot more information involved now. And we can see some other things to look at. Yeah, so you can just keep, there's lots, it's all getting cross-linked and referenced. So you should be able to get into the help and start really understanding what's happening very quickly. Let's look at a couple other elements. So we had talked previously about AC sweeps. So here's the AC sweep. If you click help here, we're going to be giving you, so you're going to need to use these other probes, and there's going to be AC sweep probe, other information for help, links to specific examples, and then linking to tutorial videos. So you can click on these tutorial videos and it's going to then link you back to how to perform an AC sweep. It's going to launch you to the web page that's going to have that information for you on it. So you can go in there and watch these videos. This help really, I feel, is going to be really useful for folks. Okay, so here we go. So this is that machine simulation. So we've run a few milliseconds of this. Let me just, I'm going to stop the simulation. We can look at something new here. So stop. So we'll look at the common mode current right now. And we can run an FFT of this. And we can change the x-axis is in log already, but the y-axis we want to go to dB microvolts. And then what we're allowed to do is overlay onto this an EMI standard. We've added in a bunch more EMI standards, but you know, FCC class A and B, put those on, and we can see that we are not, we're violating those EMI, the conducted emissions values here. So there's definitely more that can be done here, and you can add your own. So we added in a bunch of new standards with version 2020. So some of these CISPR ones, and you can add your own standards in as well still. That's definitely still allowed. But this is, you know, a really nice feature that you can use for these kinds of simulations. Other new features. So when it comes to switch controllers, we've got these elements now. You can add dead time to them. So when it comes to these elements, adding in dead time to these control elements for controlling of gating is allowed. That's a new feature. There's also a comparator with dead time as well. So this one also has the ability to define dead time. So making it a lot easier to kind of use some of these elements. That's when it comes to simulation. Coming to RidleyWorks. So with RidleyWorks, essentially what you're going to do is you're just going to click, is you're going to do your work inside RidleyWorks, design your converter, and you click this PSIM link, and then that's going to output a file right here. So there's all of, in RidleyWorks, the topologies you're allowed to use. Let's just open them up. There are all these variations with voltage mode control or current mode control, and essentially you choose the one you're going to do, you click PSIM link, and then it exports that converter as a template. That gets saved into your documents. So documents, PSIM, RidleyWorks output is going to be in here. So these are where they are. And then you can run this, and then you can run the AC sweep. If you come in here and you change this flag from a 1 to a 0, it's going to be either the transient simulation or the frequency response. So you can do that. Other questions, things to deal with. So yeah, when it comes to scripting, some script tools. So we'll open up an example here. I'll open up the LLC web example I did from a couple weeks ago from a different webinar that I did with Amit. Let's look at that. Okay, so if you were to download those simulation files from that LLC webinar, you would see, you can come in here, and if you double click on this and then click F1, it's going to tell you what that function is doing. So get local, and I've got param path, so it's fetching the parameter path for that. If we come down here as well, let me pick up, say, you know, simulate. What's that going to do? Simulate right here. This is running. I've got total, and we're see what I'm defining total time and time step are in here as well. It's returning a graph. You can see how the parameters get defined. Add to array, what's that doing? Click F1, and we've got more information there as well. So there's a lot. You can go through this and look at all of the custom functions and see what's going on here. Right, so the question about smart control. So smart control is a separate software package that we sell from PSIM, and it is for controller design. So definitely, if you look at any of the design videos that are built into PSIM, so if you go to help video tutorials and you go to power supply design, any of these videos that are in here use smart control for the controller design. So definitely go and have a little look at those, and it should be of interest. So it can be purchased separately from PSIM. It can be purchased with PSIM, but it is a separate package. Okay. What other things are on my list of things to talk about here? So please do ask questions as I work through some of these other things here. We have been making additions or changes to the. Here, let's just run this. We'll use this Ridley Works output here as an example. So we'll run this simulation. Output voltage. Great. Okay, so when it comes to this waveform viewing, these are some changes that happened last year potentially, or last version, but we've been making some edits to them as well. So when it comes to measurements of waveforms now, this box used to dock underneath here. You can now have the option of docking it or of having it be floating. Okay, so and then when you move the cursors around, it's in there. The other thing you can do is if you zoom in, for example, we can change this to be, say, 200K. So we can, we can make this delta, say, 5 microseconds, and we can fix that. And then when we click the lock button there, we can move through here, and we've got this going on. We can auto scale the y-axis. We can have multiple plot screens with multiple things going on. So I can add over here, say, the error and the voltage, the V out, and I can have those on multiple axes as well. So definitely there's a lot going on here to look at. Those are there. Other things to talk about. Yeah, definitely you can add more features here. Find the global maximum. What's the average? What's the RMS? Those things like that. Other things. So the Typhoon Link. Essentially, with the Typhoon Link, what would happen there is, if we open up a new simulation here, so if you're going to link to Typhoon, you need to be using these switch modules. These are the same ones that are compatible with DSIM. And what you're doing is you're defining the digital input that the gating waveform is going to come in on over here, so the DIO for the Typhoon system. And then there's also a special element called the core coupling element that you can use as well. And what this is going to do is it's going to help you partition your simulation properly when you move it to Typhoon. And so when you click the Typhoon button up here, it's going to export it out to the Typhoon system, and it's going to look like something like this after you've exported. So then you can just compile this and launch it directly launch it on the Hill system. So this is just the power stage. Let's look at so there's a question if there's new additions to the photovoltaics. So the renewable energy module, so there are there's this selection of PV panels. There's a PV panel that's compatible with DSIM, and then there's all the battery models in there as well, but there's no real new updates to these elements within version 2020. Okay, we're talking about linking to Typhoon. File, open examples, or no, it was in my webinars. PSIM Sims. Right. So this would be what happens. So this power stage gets transported is what ends up over here. And then the idea is that you would then use code generation to convert this into code and then run that and have the code on the processor actually control the hill simulation. So this is also looking at the XBAR support. So this is running peak curve mode control, and we're using comparator trigger signal to shift the phase shift on this. And then we've got the active secondary being generated from the control signal. So that is the equivalent of basically code generation of something that looks like this, where we've got the this is a little easier to visualize than how the XBAR implementation is, but we've got the primary side switches generating what the secondary side switches will be for the active rectification. You know, there's other improvements or changes to colors and line thicknesses that you can change. Default text fonts. So there's things you could poke around in there. No, there's not a transformer-based thermal model in PSIM to compute losses that way, no. You could make, in the thermal module, there is an inductor, and you could use that as the magnetizing inductance. But when it comes to losses in magnetics, the Ridley Works tool, design tool, has core and winding loss, proximity loss models, which can be exported into PSIM. So definitely with Ridley Works, so here's, this is a core model here, and this is a proximity loss model, and these are basically large LC ladder circuits, and these are frequency dependent, so these give a good loss calculation, and these can be simulated by PSIM. And so those parameter sets, when they are in here, so this is here's the core model for the transformer. And so this is an RL ladder. And you can see there's some very large inductors here. So 10 Henrys, 36 Henrys to provide you with the right frequency characteristics. Same with the inductor here. And the proximity models haven't been calculated, but they are also large RL ladder networks. Can you set the cursor measurement to microseconds or picoseconds? So it's in microseconds right now, so milli to milli, microseconds. If I just keep zooming in, it should just keep, so it's still micro. Well, let me turn that, unlock that. So now it's in nanoseconds. So if I don't think I have a small enough time point to make it pico or picoseconds, but yeah, it'll just keep on zooming in. And you can adjust the number of significant digits that are shown here as well. Yeah, so if you have a question in the next few days, do not hesitate to let us know. We're happy to help. You know, when it comes to future versions of PSIM, we're now going to be on the 2020 ABC, 2021 ABC, 2022 ABC model instead of major and minor release versions. We hope that this will provide a little bit more of a standardized release schedule. And then from that also, when it comes to the next release of PSIM, there's going to be changes to the GUI coming up where we're going to allow bus wiring and some other features of that like that to help with larger inverter style larger inverter developments in PSIM. Yeah, and then we're obviously there's going to be some other optimizations coming to the engine as well that we're trying to bring forward as well. So definitely there's no real improvements to simulation speed in this particular release, but we're thinking of new ways to speed things up to make our lives better. And then we're also going to be, with regards to the scripting, we're looking at Monte Carlo style simulations and design verification style modules or features to help with making use of the scripting to its full abilities. So you don't have to sit there and write your own scripts potentially, but being able to use the scripts from a utility or a wizard instead of learning the coding language, which is kind of the C hybrid. So that's some things to look forward to, hopefully some of those things coming towards the end of the year. Okay? That's it. Thank you so much. Please, yeah, as I said, follow us on LinkedIn, etc. To keep track of what's happening. Thank you, everyone. Yep. Thank you for coming.
Thank you. Have a great day. Bye-bye.